In this video, we are going to talk about pollution control, and we are going to look at three policies. We are going to look at command and control, an emission tax, and also a cap and trade policy. Now, let me start with the cap and trade policy, because there are instances in the United States where that policy has been implemented. Basically, what a cap and trade policy is that the regulator or the government determines a cap of pollution, of what is the maximum allowable pollution level, and then the government distributes permits that gives firms the right to emit 1 ton of pollution. So in the sense that if the firm has a permit, then the firm can use that permit to pollute. The advantage of the cap and trade system is that once you have set the level of pollution, you can distribute the permits simply by simply to the firms, and you're only distributing the number of permits that are equal to the pollution level that you desire. And then there is a market that emerges in the sense that firms can purchase and sell those permits on the market, very much like shares. Now, one example that I would like to look at is the acid rain program. Okay, and you have here a document from the EPA. Okay, and basically it is the emissions or the power generation emissions of SO2. Now, SO2 is sulfur dioxide, and together with nitrogen dioxide, it can actually react in the atmosphere and form various acid compounds. And there are health concerns associated with those compounds. Now here you can see that the green line are the actual emissions, okay, of SO2 in the United States, and the blue line is what those emissions probably would have been in the absence of the acid rain program. But note that the regulator or the government set an allowable emissions limit. This is the cap, and that the cap was set relatively high at the beginning and then dropped significantly in the early or before 2000. Okay, so what you can see is that in this case here, the firms actually reduced their emissions below the cap, and in this case, this is actually called a banking of emissions, in the sense that firms can reduce their emissions below the cap, and they can keep those permits to be used later. And this is what they then did after in the early 2000s, when the actual emissions were slightly higher than the allowable emissions, because they were able to use the permits which they had banked in the previous periods. Now note that, and you can show this, that the distribution or the initial distribution of the permits does not affect the efficiency of the program. Of course, it does affect of how much permits firms have to purchase and sell, but the overall efficiency is not affected. Now, let us have a look at an animation that looks at the deposit of SO4 over time. So this animation is taken from the National Atmospheric Deposition Program, and we have the SO4 as a PowerPoint. Now, let us have a look at the animation to see how the deposits evolved over time. Let us have a look at some pollution control policies. Now, suppose that we have two firms, firm 1 and firm 2, and that both firms are emitting a pollutant. And the pollutant is the same for both firms. Suppose that firm 1 is emitting 30 tons of pollutant and firm 2 is emitting 20 tons of pollutant. So the initial pollution or emissions is 50 tons, 30 plus 20. Now, suppose that both firms have different abilities to abate pollution. Abating means reducing. So here, A represents the amount abated or the abatement quantity. And so for firm number 1, we have a total cost of 3 times A or the abatement squared. And we have a similar function for firm number 2. So the total cost associated with abatement for both firms looks approximately like this. Now here the justification is that if the firm is going to abate more and more or is going to reduce more and more pollution, that it gets increasingly more expensive, okay? In the sense that if you really want to reduce pollution, then at a certain level it gets very expensive because you have to invest in more expensive equipment, okay? Now, the marginal cost associated with both firms, or the marginal cost associated with abatement, is 6 times A1 for firm 1 and 4 times A2 for firm 2. Okay? So here, this basically assumes that the marginal cost of abatement is a straight line. Now, remember that the relationship between the total cost and the marginal cost is the slope. Okay? In the sense that the marginal cost represents the slope of the total cost function. Okay, and you see that this slope is increasing as we increase abatement. So this is the initial situation in terms of pollution and the two firms. Now, suppose that the government has a pollution goal of 40 tons, in the sense that the government thinks that 50 tons are too much because it causes an externality that hurts non-market participants, and hence the goal is going to be 40 tons. Now, the government considers 3 policies. Policy number 1 is what is called a command and control policy, where we assume a proportional reduction in emissions. The second policy is an emission tax, where there is a tax of $24 per ton of emission. And then the third policy is what is called a cap and trade, where the cap is set to 40 tons. Okay? And what exactly those 3 policies mean, I will go through in detail right now. So let us first have a look at the command and control policy. Here we are talking about a proportional reduction, okay, in the sense that we are initially at 50 tons of pollution. We are looking for 40 tons of pollution, okay, so hence the abatement has to be 10 tons, okay, and we are looking at an abatement proportional to the initial pollution levels or emissions from the firms. So what this means is that firm number 1 has to abate 6 tons, and firm number 2 has to abate 4 tons. Okay? Now note that if you have A1 plus A2, that gives you 10 tons, which is exactly the reduction necessary to achieve the 40 tons. And since firm is initially emitting 30 tons, they have to reduce 6 tons, and firm number 2 is emitting initially 20 tons, and hence they have to reduce them by 4 tons. So let us look at what the cost of this policy is. Okay, so here we have the command and control policy. Okay, and what we will see is that the command and control policy is inefficient compared to the 2 others. Okay. Inefficient means that for the same amount of pollution reduction, it is more expensive. So here we now have A1 is reducing by 6 tons, or the abatement of firm 1 is 6 tons. The abatement of firm 2 is 4 tons. And hence we can calculate the total cost associated with firm number 1, which would be 3 times 6 squared. Okay, so this would be, so 6 squared is 36. 3 times 36 is equal to $108. So that is the total cost for firm number 1. And for firm number 2, the total cost is 2 times 6 squared, 2 times 4 squared, and hence the total cost for firm 2 is equal to 32. And hence for the command and control policy, the total cost is equal to $140. Okay, so that is the cost in terms of abatement of the command and control policy. Okay, this abates 10 tons. Now let us have a look at a second policy. Okay, and let us have a look at the emission tax policy. Okay, now note here the tax rate is set to $24. Okay, and so what this means is that firms can continue to pollute, but for each ton they are polluting, they have to pay a tax of $24. Okay, now suppose that you are a firm and you know that for each ton you pollute you have to pay $24. But suppose that you can invest in abatement technology, and suppose that abatement technology is able to reduce that abatement technology, okay, has a marginal cost of say $23. Okay, now this is just an example. So what this means is that you can pay either $24 in tax, or you can pay $23 in the abatement technology to reduce to reduce 1 ton of emissions. So in this case, you would of course invest in the abatement technology, because the abatement technology only costs you $23 as opposed to the $24 in the tax. Now suppose that the marginal cost of abating is actually equal to $25. Then here it would cost you $25 to avoid a ton of emissions, but you would only pay a tax of $24. Okay, so hence here in this case, with the marginal cost of 25, you would continue to pollute. And hence, and this is important, the optimal condition is where you have to set the tax equal to the marginal cost of abatement. Okay, so that is the firm's decision in order to know of how much they are going to invest in abatement. So let us just do this with the numbers we have above. Okay, so we know that we have the marginal cost for firm 1 is equal to 6 times A1. The marginal cost for 2 is equal to 4 times A2. And hence we have to set those marginal costs of abatements equal to the tax rate of $24. So we have 24 is equal to 6 times A1, and 24 is equal to 4 times A2. And hence this leads to abatement amounts of 4 units for firm 1 and for 6 units of firm 2. Okay, so note that this result is different from what we have above in the command and control policy. Now the command and control policy, we have an abatement level of firm 1 of 6 tons. Here we have 4 tons. And we have 4 tons for firm 2 in the command and control policy, whereas we have 6 tons in the emission tax policy for firm 2. Now let us consider of how much it actually costs those firms to abate those quantities. Okay, so here we can calculate, or we can plug in the abatement amounts into the total cost functions. So the total cost for firm number 1 would be 3 times 4 squared, and the total cost for firm number 2 would be 2 times 6 squared. So here we are having 4 squared is 16, 3 times 16 is equal to $48. And for the total cost for firm number 2, we have 6 squared is 36, times 2 we have $72. And hence the total cost associated with the emission tax is equal to $120. Okay. Now note that there are two things to note here. First, with the emission tax, we are getting 10 tons of abatement. Okay, this is the goal. And to get 10 tons of abatement, it only costs us $120 as opposed to $140 of the command and control policy. Okay, so hence the emission tax, if set at the correct level, is more efficient in terms of cost to society. Now note that here I have picked the emission tax at 24, which coincides with the abatement. Okay, so I have picked this amount specifically to achieve the abatement necessary. And I will get into more details about picking this emission tax amount later on. Okay, so here we can see that we are having $120 cost, and note that the transfer from the tax transfer that the firms have to pay is only a transfer of wealth, basically going from the firms to the government, and does not really consist of any deadweight loss. Now note that this is not the only cost for firms 1 and 2, because if you look, we know that firm 1 is polluting 30 tons at the beginning. Okay. They are abating 4 tons. And hence they are still polluting 26 tons. And for firm 2, their initial pollution is 20 tons. They are reducing it by 6 tons. And hence they are polluting 14 tons. Okay. Both firms have to pay an amount of $24 on those emissions. Okay, so the tax for firm number 1 would be 24 times 26, and for firm number 2 it would be 24 times 14. Okay, so there is still a tax burden associated with the firms, or with the emissions. Okay, that has to be paid by the 2 firms. Okay. Now, the general concept of why we have this reduced cost, okay, is in the marginal cost functions, or the difference in marginal cost functions of the 2 firms. Since here we are talking about the same pollutant that is emitted by both firms, it doesn't really matter which firm emits those pollutants or reduces the emissions if we want to have a pollution goal of 40 tons. What the regulator or the government wants to do is that the reduction of 10 tons is achieved in the least cost way. Okay? And it turns out that this least cost way is done either with the emission tax set at the correct level, or we can also look at a different policy, which is called the cap and trade. Now, cap and trade is different from the emission tax, but we will see that it is also efficient, okay, and that it does not involve transfer of money from the firms to the government, but between the firms. Now, let us have a look at the third policy, which is a cap and trade policy. Okay, so here in this case, the cap is set to 40 tons, okay, because that is the emission goal of the government or the regulator. And keep in mind that the initial emissions are 30 tons for firm 1 and 20 tons for firm number 2. So here in this case, okay, assume that there is an emission price out there, or not an emission price, but a permit price, okay? And how we are going to calculate this permit price will follow in a bit. So think about, there's a permit price, okay? And keep in mind that each permit, okay, has gives the firm the right to emit 1 ton of pollution, okay? Suppose that the firms can purchase an emission permit, and suppose that cost is $20, okay? Now, in this case, the firm can purchase the right to emit 1 ton of pollutant for $20. Okay? Now, suppose that the marginal cost of abatement, okay, is say $21. Okay, so in this case, the firm can either purchase an emission permit at $20 that gives it the right to pollute 1 additional ton, or it can abate that additional ton at the cost of $21. In this case, the firm would of course purchase the permit that gives it the right to emit 1 ton, because the $20 is cheaper than the $21. If the marginal cost is equal to 19, or the marginal cost of abatement is equal to 19, then in this case it is cheaper for the firm to invest in the abatement technology because it only costs $19, than then spend $20 on their permit price. And hence, in equilibrium, we have the permit price, or the let's call it P, is equal to the marginal cost of abatement for the firm. But note that since we are having 2 firms, and each firm is setting the price at the marginal cost equal to the permit price, we have the condition that the permit price has to be equal to the marginal cost for firm 1 and also the marginal cost for firm 2. Now, how we do the calculations is the following. What we know is we have to set the 2 marginal costs equal to each other. So we have to say 6A1 is equal to 4A2. But here now we have the problem that we have to find the abatement levels, A1 and A2, but we only have 1 equation so far, and we have 2 unknowns. Now, in order to solve for 2 unknowns, we need 2 equations. Now, the second equation, which links A1 to A2, is actually the cap. In a sense, we know that the abatement of firm 1 and the abatement of firm 2 has to be equal to 10, okay? Because remember that the cap is 40 tons, and hence they both have to abate 10 tons. And also keep in mind that the government has only distributed 40 emission permits to the market. Okay. So now we have two equations in two unknowns. So we can say, for example, we have A1 is equal to 10 minus A2. And then we can plug this back into the first equation. So we have 6 times 10 minus A2 is equal to 4A2. So now we have only one equation in one unknown. So we have 60 minus 6A2 is equal to 4A2. And when you solve this, you find that A2 is equal to 6. And hence A1 has to be equal to 4. Okay? And now you can see that we have the abatement levels. And now you can calculate all the remaining aspects of it. So let us first calculate the permit price. So we know that the permit price is equal to the marginal cost across the firms, because we have the abatement of 6 for firm number 2. So if we plug in 4 times 6, we find that the permit price is equal to 24. Okay? And now note that it is not by chance that the permit price is actually equal to the emission tax. And I will come to that in a bit. So we have the permit price of 24, and then we can also calculate the total cost associated with abatement for firm number 1 and for firm number 2. And note that since they have the same abatement levels than under the tax scenario, that also the total costs are going to be the same, in the sense that the total cost for firm number 1 is going to be $48, and the total cost of abatement for firm number 2 is going to be $72. And hence we have the total cost of abatement. Okay, let's write this as total cost of abatement is equal to $120, which is identical to the result in the emission tax scenario. But note that here the situation is slightly more complicated, because the regulator has distributed 40 emission permits, and suppose that the regulator or the government distributed those emission permits equally, in the sense that for firm number 1, they have 20 permits initially, and firm number 2, they also have 20 permits initially. Okay? Now, since firm number 1 is abating 4 tons, okay, and they are emitting 30 tons initially, they are still polluting 26 tons. But they only have 20 permits. Now note that the emissions of firm number 2 after the abatement is 20 minus 6. So they are emitting 14 tons. Okay, but they have 20 permits. Okay. Now note that what this means is that firm number 1 needs to purchase 6 permits, and firm number 2 is selling those 6 permits. And they are selling those 6 permits to firm number 1. Okay? And of course, we have this price of $24. So firm 1 still has to spend 6, since they have to purchase, say they initially have 20 permits, but they need 6 additional permits. So firm number 1 has to spend $24 times 6 permits. Okay, and note that this is a cost to them. And firm number 2, since they have already 20 permits, but they only need 14, they are selling those 6 permits. Okay, so what the expense is to one is the revenue to the other. Okay, and hence there are important differences. Compared to the situation where we have the emission tax, right? In terms of the emission tax, the total cost of abatement is $120, which is the cost to society. And here we have a transfer of tax revenue from the firms to the government. But this only represents a transfer of wealth. Now, in the scenario of the cap and trade system, we have, again, a total cost of abatement $120, which makes the emission tax and the cap and trade efficient systems or efficient policies with the same outcome. So to economists, cap and trade and emission tax are equivalent. But here we do not have a transfer from the firms to the government, but here we have a transfer of wealth between the firms, okay? Because one firm has to purchase permits, and the other firm has to sell permits. So both firms, okay, may have very different stances, what they prefer in terms of cap and trade, right? The firm 2 probably prefers the cap and trade system because they're getting revenue from the emission tax. They're getting a revenue from the permit sales. Okay. So this is a summary of an overview about the cap and trade system, as well as the emission tax and the command and control. And the takeaway is that the command and control is not efficient because it is more expensive compared to the emission tax and the cap and trade. The 3 policies that I have presented previously, the command and control, emission tax, and the cap and trade policy, in the way I presented them, I made some very simplifying assumptions. For example, you could argue that the command and control policy could be made efficient if we set the command and control quantities to the abatement levels that are resulting from the emission tax or the cap and trade system. Now, the big problem is with all 3 policies is that the marginal cost of abatement of all firms, okay, or of the firms that you would like to regulate, is unknown. Okay. So you do not know how much it actually costs for those firms to abate emissions. Now, this leads to multiple problems, okay? And some of them can be solved, whereas some of them cannot be solved, at least not simultaneously. For the command and control policy, theoretically, you could set the optimal or the efficient level of abatement if you knew the marginal cost of abatement, which you do not, okay? And hence it would be very difficult to actually set or make the command and control policy efficient. Now, with the emission tax and the cap and trade system, it turns out that both policies are efficient. And we will see that the cap and trade system is what is called a quantity instrument. Okay, Because remember, with the cap and trade system, you are setting the quantity of emissions or the quantity of abatement that you want, and then you let the firms trade. Whereas the emission tax, you are setting the price on emissions, and then you are letting the firms abate to the optimal level. Okay. The problem is that if you are setting the quantity under the cap and trade, if you're setting the abatement quantity, and since the marginal cost of abatement is unknown, with the quantity instrument, you do not know of what the permit price is going to be before its implementation. In reality, the permit price will evolve or will be clear after the policy is implemented, but not before. And hence, with the quantity instrument, such as the cap and trade, the quantity of abatement is predetermined, but the permit price is unknown. With the price instrument, such as the emission tax, you have the opposite problem, in the sense that you are setting the price on emissions, but you do not know the quantity of abatement. If the price is too low, the quantity, or if the emission tax is set too low, then you may not have abatement, or you may have just very little abatement. Whereas if the price or the emission tax is too high, you may have too much of an abatement. Now, in reality, in the policy instruments, okay, or in legislations, to solve the problem associated with the cap and trade system, in the sense that you do not know of what the permit price is going to be, because remember, the higher the permit price, this results also in additional cost to the firms. What they do is they usually implement a price collar in a cap and trade system. So what this means is that is best illustrated in a graph where you have time on the horizontal axis and you have the permit price on the vertical axis. Now, what this price collar under a cap and trade system does is the following. So you start the cap and trade system with suppose an initial price, and then very much like the stock market, since those are tradable emission permits, the price is going to evolve up and down. But the price collar, okay, sets an upper price and a lower price on the permits, in the sense that if the permit price hits the upper bound of the price collar, then the government is actually going to emit more permits to the market, okay, to make the price go down, okay. So this price collar, okay, limits the permit price that cannot be exceeded, okay. So that is one way of containing the price uncertainty associated with a cap and trade system.